right, Precalc, let's talk ellipses. We did ellipses last year. And just a reminder, these conic sections are cones that are intersected by a plane and they make shapes. So I'm going to show you that in class. We are on lesson 9.2. We're talking about ellipses, and our essential question says, how do you solve problems involving ellipses? So we're going to start with the standard equation of an ellipse. And I always tell my students, you don't really need to know where the major axis is. But if you notice, there is the major axis, need a highlighter, is where the a squared is. So notice that the major axis is horizontal, the major axis is vertical. So when it's horizontal, it looks like this. And when it's vertical, it looks like this. And you could tell that because you don't really need to know which one's A, which one's B. So we have x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. So notice there's a bunch of variations. The only thing that changes is the a squared jumps to under the y. And we're going to see how that works. I don't have the foci written out here, but I do have that these right here go through the origin, kind of like what I drew for you. That one right there goes through the origin. So instead of having an HK, it's going to go through the origin of 0, 0. All right, before we talk foci, let's look at one. If I had x minus 2 quantity squared over 4 plus let's do y plus 1 quantity squared over 9 is equal to 1. All right, if I have to graph this, the first thing I'm going to do is graph my HK. So I know that my H is at 2, my Y is at negative 1. So that is kind of like what we would call the center, but it's going to be an ellipse, so it's not exactly the center. Now I'm going to look under the x and I see this 4. Remember, it was an a squared and a b squared. In this case, this is the b squared because it's a smaller number. And if I take the square root of 4, I'm going to go 2 to the right and 2 to the left. Under the y is a 9. The square root of 9 is 3. So I'm going to go 3 up and 3 down. And I'm going to draw my ellipse. So let's talk about a couple things of my ellipse. The HK is what we would call the center, and in this case it was 2, negative 1. We have what we call a major axis, and sometimes you're only given the major axis. Well, if you notice, we went 3 this way. 9's bigger than 4, so that's where the major axis will be on the y. And 3 this way. So in this case, my major axis has a length of not 3. 3 plus 3, which is 6. The other thing, which we didn't get to a ton in class, is that an ellipse has foci. I'm going to erase these little lines that I made here and plug back in this. So an ellipse has foci. What I tell my students is, you see how this ellipse is being added? Well, when we get to hyperbolas, you're going to notice that the foci will be subtracted. So we are going to take the largest, subtract the smallest, and we get the foci squared. So what I mean is I'm going to take the largest number in the denominator, 9, subtract the 4, and that will be my c squared. Well, 9 minus 4 is 5. And if I had to actually name the foci, I would actually have to take the square root of each side, where c is equal to root 5. So what that means is it's going on the y-axis. So if I had to name the point of the foci, it's going on the y-axis. So I'm going to have 2, negative 1, but I'm going to add root 5 and subtract root 5. Now I know root 5 is like 2.1-ish, so I never really have to draw these in, but just in case you have to, you know where they are. They're going to be inside. It's as if we put two parabolas put together and we have these little foci in the center. So just like how the parabola hugged the focus, the ellipse hugs two foci. All right, so you'll see why I didn't start with example 1. Example 1 says, find the standard form of the equation of the ellipse having a foci at -2, 2, and 4, 2, and a major axis of the length of 10. Guess what I'm going to do first? The same thing I always do. I'm going to graph this. I know at -2, 2. Oh, I have a foci, so why don't I draw it as a little foci? I always draw the foci as stars. And +4, 2. And the reason they give us this is because right from here, I can see that this has a length of 2 and 4 has a length of 6. So I know that 6 is halfway, half of 6 is going to be exactly where my center is. I also know the foci are where the major axis is, so I already know that this is an x squared. And they're going to equal 1. I also know that my center is at 1, 2, so I can put those numbers in, -1, -2. And here they told me that my major axis has a length of 10, so this was 3, and I know that this is going to be my major axis. It's going to go 5 to the left and 5 to the right. So if this distance right here is 5, underneath my x squared, I need 25, because remember that's going to be the a squared. Now I'm going to erase this so I can draw the rest of it. All right, the foci. I know the foci. I could take the a squared minus the b squared, and that's going to give me c squared. Well, remember c squared is this distance from the center to the focus, foci. So if I have a squared minus what is going to give me, well, that was 1, 2, 3 spaces away. So that's going to be a 9. So when I subtract, I get -b squared equals -16, and I know that b squared, isn't that funny? B squared equals +16. So the equation of this ellipse is x minus 1 quantity squared over 25 plus y minus 2 quantity squared over 16 is equal to 1. Ellipses and hyperbolas always equal 1.